Hello everyone, welcome back to my YouTube channel, Quantum Computing. Before proceeding to the quantum logic gate, we'll recall the classical logic gate. We'll see the structure of it and how it works. Here is the pictorial representation of the types of digital logic gates. Okay, AND gate. Outputs 1 if and only if all the inputs are 1. That means, suppose if you are taking a consider two bits A and B, okay, and you are finding A and B. Okay, so 0 0 0 1 1 0 1 1. These are the four possible combination for the two bits. Okay, now what does the statement tell? Outputs 1 only if all the inputs are 1. That means both the gates A and B gate should have the same input 1. So only in the fourth row you are having 1 1. So this will result output 1. Rest others will be 0 0 0. Correct? Similarly, OR gate outputs 1 if at least one input is 1. That means either input A or input B should have at least one true value. Then only the output will be true. That means A, B, A or B. Again, inputs will be 0 0, 0 1, 1 0, 1 1. What does the statement tell? It outputs 1 if at least one of the input is 1. That means you need to identify whether the two bits is having whether input as 1 or not. So in this scenario, if you see in the first row, there is no 1 either in A or either in B. So it will result in 0. What about in second row? 0 1. So we are having 1. So it will be 1. Again 1 0 1. 1 1 is again 1. Okay. Now we'll see how NOT gate works. Okay. Outputs the inverse of the input. That means if my input is 1, it will give output as 0. If my input is 0, it will result output as 1. Okay. NAND gate outputs 1 only if not all inputs are 1. That means there should be no input with 1. Okay. NOR gate outputs 1 only if all inputs are 0. That means all the inputs should be 0. That means 0 0. The inputs are 0 0, then only it will result output 1. In rest other 3 cases, it will result 0. 3 cases, it will result 0. Sorry. Now XOR gate outputs 1 if inputs are different. That means you suppose let's say you are having 0 0. Since both the inputs are same, what it will result? It will result in 0 again. 1 1. Again both the results are same, so it will result in 0. Let's take outputs 1 if inputs are different. So what we need to take? 0 comma 1. So it will result in 1 because the inputs are not same here. Okay. XNOR is the gate which is the opposite of the XOR gate. That means vice versa. In XNOR gate, what happens? The inputs 0 comma 1 will become 0, whereas the inputs with of both the bits is same, it will result in 1. Simple, right? Okay. Now we'll see logic gate operation framework. What happens? input signals. First, we need to pass the input signals. Let's take, we are having two inputs. We are passing the signal. Okay, one. Here also we'll pass one. Next, we need to apply any logic gate. So which one we should take here? We'll consider which logic gate? Okay, we'll go with OR gate. Okay, we'll go with OR gate. Now, after passing the OR gate, what will happen? What happens in OR gate? If both the inputs are 1, 1, result will be 1. So, it will result in 1. That is how the Boolean algebra works here. Then identifying the true or false. We all know 1 stands for true and 0 is false. Correct? So, it will result 1 as the output. That's it. Similarly, this is the logic flowchart for AND gate. We'll take an input, we'll take an input B, then we'll find A and B, then we'll check how the result works. This is similar to, again, the solution will be very similar. It's again drawing a truth table for two inputs. So the inputs are A, B, and we are finding A and operation B. Okay. What happens? Let's take two inputs. So 0, 0, 0, 1, 1, 0, and 1, 1. So what happens in 0, 0? It will result in 0. What is the AND gate condition? We need to have both the inputs should be same. I mean, both the inputs should have the true values. Okay, then only it results in output 1. Remaining other scenarios, it will result in 0. Perfect. Same, OR logic gate. I have explained the OR logic gate truth table in the starting itself. You can refer here. Okay. Truth table OR gate. And NOT gate. It is very simple to understand. If our input is 1, it will result in output 0. If our input is 0, it will result output 1. That's it. So in the next class, we'll see what does quantum gates do, how it helps in building a blocks of quantum computer. Okay, see you guys in next video. Until then, subscribe, like, watch, and comment. Thanks for watching.